Hello again, pre-algebra students. This time we're going to be working on two-step equations. So you guys have probably felt like I've had you practice and practice and practice so much of one-step equations. Now we're going to go to equations that are two steps. All right? And so for two-step equations, you may want to do what I showed you before, to draw a line down through the equal sign to help you separate the two sides. And then think about what operations and where the variable is so that you can get the variable by itself. Because remember, we want to isolate that variable. So we're going to undo things. So we're going to go the opposite order of operations. We're going to do adding and subtracting first in general. There is kind of an exception that. And then multiplying or dividing last. And then to check it, remember that you can substitute, plug in, replace your answer for the variable, and then check to make sure that your left side and your right side are actually equal to one another. So you see you've got some here that are already done for you. You can go back over those. I'm going to go on to some that are not already done. We'll look at this one here that says let's solve this together. And I'm actually going to write out in words what I'm doing over on the first step, second step, and I'll write the equation over here to the right. So my equation, I'll go ahead and put my line down through here. And so first step, I need to get rid of that 2, so I'm going to subtract 2. So my first step is subtract 2. And of course, both sides of the equal sign. And then we can actually simplify that. Now this is just 4x, because plus 2 and minus 2 makes 0, and 4x plus 0 is just 4x. 10 minus 2 is 8. And then now my second step is going to be to divide both sides by 4. And we get x is equal to 2. And let's go ahead and check that to make sure. So 4 times x, which is 2, so 4 times 2 plus 2 should equal 10. 4 times 2 is 8, and 8 plus 2, feeling pretty good about this, 8 plus 2 is 10. So the left side and the right side are the same. Pat yourself on the back, give yourself a high five. Whoop, whoop. Little whoop, whoop. We got it. All right, so that one is done. Nice. So 2 steps. You can also think of the constant needs to move to the other side, and then we're going to get rid of the coefficient at the end when it's multiplication. So here's some 2-step equations. I'll do a few of these. Let me go down here to where we have some with some negatives. That usually throws people a little more. Don't want to just do the easy ones and then leave you with the hard ones. So let's see if I can move this down just a little bit more so that we can, maybe not. All right. So for number 3, I'm going to add 10. Well, I'm going to put my line here and add 10 here. So when I say on both sides, under the negative 10 that I'm trying to get rid of, and then on the other side of the equal sign, those cancel out. I have negative 4r. Be sure you bring that negative sign down with the 4r. That's equal to 26 and 10 make 36. then we'll divide by -4. When we're dividing, if the signs are different, the answer will be negative. So I get -9. To check that, -10 minus 4 times -9 is my variable's value, r in this case. So multiplication would have to come first. This would make this plus 36. So -10 plus 36, that is 26. So yes, it works. 5 and 6, those have fractions in them. So we're still going to undo our addition or subtraction first. So I've got an add 5, so I'm going to subtract 5. Both sides of this equal line. So v over 3 now is equal to 10 minus 5 is 5. And then to get rid of division, we need to multiply. So I'm going to multiply this side by 3 and this side by 3. Remember, this makes 3 over 3, which is 1, so they cancel out. And then 5 times 3 is 15. So I could check that. 15 over 3 plus 5 should equal 10. 15 over 3 means 15 divided by 3, which is 5. 5 plus 5, 5 plus 5, 5 plus 5, I think we can both all agree is 10. All right, so there's a couple examples. Keep in mind there are some other examples already worked out in your packet the way it was printed. So let's see what we have coming up next. Okay, so these problems are kind of special case because usually we've been adding or subtracting first, but here I'm going to multiply first because the whole thing is in the fraction. I cannot just reach into the top of the fraction to subtract the 3 because that 3 is also being divided by 6. So in this case, I have to multiply by 6 first. So I'm going to do this on both sides. So in the left side, I don't actually multiply the 3 or the x by 6. They are just now free of the fraction. And on the right side, where there was no fraction, I actually do -1 times 6 is -6. On the left, I do multiply by 6, it's also being divided by 6, so they just undo each other. And then take away 3. So now I have x is -6, -3, x is -9. So if there's more than one thing in the fraction, then we have to get rid of that fraction first. And careful here, that kind of looks like it's positive. So another example, here number 10, if I multiply both sides by 3, again, 3, I feel like I've done 3s a lot. I have n plus 8, but the fraction is gone. On the other side, 8 times 3 is 24. Now I can subtract 8 on both sides. So n is 16. And again, we can check these two. 16 plus 8, the whole thing divided by 3 should equal 8. 16 plus 8, remember how the fraction bar can be a grouping symbol? That would mean 24 over 3. And yes, 24 divided by 3 is 8. It works. Hooray and hurrah. And then, so you're going to finish the problems on those last 2 pages. And then I'd also like you to write out in words the steps that you would take to solve this equation. Show the work, but also in words, like you were trying to explain to Hattie how to do this. Kind of like I did on the first page when we were looking at that. Now, let's think about what Brad did wrong here. Sometimes it's hard to look at other people's stuff. So, there's really a couple ways that Brad could have done this problem, but what he did is not right. So he multiplied first, but the 4 was not a part of the fraction. So the way I've shown you, we would have subtracted 4 first, because the 4 is not part of the fraction. So I'm going to show you something a little different. There's 2 ways that you could solve this correctly. We could subtract 4 first, since it's not part of the fraction, then multiply by 3, okay, you see we do not get the same answer as Brad did. If Brad wanted to multiply by 3 first, and sometimes my students dislike fractions so much they want to multiply by 3 first, it's actually legal to do that, to do it first. However, everything on this side needs to get divided or multiplied by the 3. So the x is being divided by 3. So that part's right. But this 4 that's not part of the fraction, because it's not part of a fraction, the 4 would get multiplied by 3 if we were going to multiply first, and it would become 12. And then if I subtract 12 on both sides, guess what? Negative 6 minus 12 would give me negative 18. So it's not that you cannot multiply first, but if you multiply first and that constant, the number being added, is not part of the fraction, it must also be multiplied. Or the other correct way to do it would be to subtract first and multiply second. But this was not a big fraction, so we were not required to multiply first. Okay, we'll have a chance to practice and look at more of those to kind of understand the difference. But typically if only the x is in the fraction, you can just save the fraction until the last step, like I did over here. Okay, so that is page 9 in your packet, and that would be your goal to finish today. Depending on how things went in class, I may have also assigned IXL lessons, okay, so that you get more practice with just 2 steps before we go on to multi-steps. It's a good plan for us to have more practice with 2 steps. So I will have assigned IXL lessons. Otherwise, after the ones I did, you only have about 5 problems, which is not very many. Okay, thanks so much.